Pleasant morning to my dear lovable students. I hope you all are fine. In this conversation, we are moving to continuation of example. Okay, I'm moving to example 1.24. Given, find the largest possible domain for the real valued function. Okay, for the real valued function given by f of x is equal to f of x is equal to square root of 9 minus x square divided by square root of x square minus 1. So, I think last or before last question we discussed about whatever the number in square root, it must be positive. If any one number in square root negative means it is not a real root, only imaginary. Okay, I am moving to the numerator. Consider for p of x. Okay, so p of x is equal to 9 minus x square. It is always positive value. Positive value means definitely we can say greater than or equal to 0. So, if you interchange the sign means what will happen? So, minus x square convert for positive means plus 9 or minus. Therefore, inequality symbol also we can convert for less than or equal to 0. So, already we know the 10th or 9th standard formula a square minus b square means what is the formula? So, a square minus b square means a plus b into a minus b, isn't it? So, a plus b into a minus b. Therefore, how to convert this line? Rearrange. So, x square 9 means we can write 3 square. Again less than or equal to 0. Therefore, a square minus b square means a plus b into a minus b. Therefore, we can write it x plus 3 into x minus 3 less than or equal to 0. Therefore, x value x is equal to minus 3 and minus 3 means we can take it for positive 3. Then take it on number line. So, minus infinity to positive infinity. Then center 0 means minus 3 to positive 3. So, minus 3 to positive 3. Now, make it on table. Table column means first one interval. Then second one the output x plus 3 into x minus 3. The last one consider for p of x, isn't it? So, p of x, first one minus infinity to minus 3, minus infinity to minus 3. So, what will happen? Minus infinity to minus 3 means this is open, this is closed. So, in between minus 4 plus 3 minus sign, again minus 4 minus, again minus sign, minus into minus plus. Next one minus 3 to positive 3, minus 3 to positive 3. 0 is there, no? Take it for 0. 0 plus 3 positive sign, 0 minus 3 minus 8, plus into minus minus. Next case 3 to infinity. 4 means 4 plus 3 positive sign, 4 minus 3 again positive. So, plus will come. But we have to consider the second line, isn't it? Because the original question 9 minus x square, we have convert for x square minus 9 less than or equal to 0. Less than means minus, only we have to take it minus. This is also wrong, this is also wrong. Therefore, so p of x is belongs to only minus 3 to 3. Closed interval minus 3 to 3. Okay. Moving to next case. Next case, this is numerator, denominator, consider for q of x. Okay, p of x already we have taken. Then q of x means what will happen? So, q of x is equal to x square minus 1. This is also always greater than or equal to 0. Now, this is also we can convert x square minus 1 square greater than or equal to 0. A plus b into a minus b. X plus 1 into x minus 1 greater than or equal to 0. Again, each and every time equal to 0 means x plus 1 is equal to 0. At the same time, x minus 1 is equal to 0. Therefore, x is equal to minus 1 and positive 1. Take one number line. Minus infinity to positive infinity, center 0, minus 1 to positive 1. Now, the same condition. Here only we are take it x plus 1 into x minus 1. X plus 1 into x minus 1. What will happen? First interval minus infinity to minus 1. Minus 1. Now, so minus infinity to minus 1. The final term in between minus 2 means minus 2 plus 1. Minus sign. Minus 2 minus minus. Minus into minus plus. Next case minus 1 to positive 1. in between 0, 0 plus 1 positive sign, 0 minus 1 minus, plus and minus minus, again 1 to infinity. True means true plus positive, true minus again positive, but here condition greater than or equal, so greater than or equal positive value only, therefore so q of x belongs true, only positive, minus infinity to minus 1, minus infinity open interval minus 1, then union of 1 to infinity, 1 to infinity. So from this true term we have to take it original possible domain. What the answer will come? Largest possible domain, largest, again on bigger number line, minus infinity to positive infinity. We have one result in between 0 is there, minus 3 and positive 3 also is there, minus 3 and positive 3, at the same time minus 1 and positive 1 also is there. So minus 1 and positive 1 also is there. In between first one, they look at their first one, so minus 3 to minus 1 isn't it, then positive 1 to 3 is there. So first in this is the interval, minus 1 to minus 3 to minus 1, another one 1 to 3 isn't it, 1 to 3 is there. Therefore the domain we can write it clearly, minus 3 closed interval, minus 1 open interval. Okay, I will explain why I have written for the open interval. Then again union of 1, again open 1 to 3 closed interval. Listen, why I have taken minus 1 and positive 1? In denominator already x square minus 1 is there. Closed means we can take it include minus 1 also. If we take it instead of x, minus 1 the whole square is there, minus 1 the whole square positive, therefore 1 minus 1 square root of 0. Any number divided by 0 means that is not defined. That's why open interval means except minus 1. Here also open interval except 1. Okay, that's why I consider for minus 1 open interval, 1 open interval, but the starting time minus 3 and this plus 3 also we can take it closed interval. Okay, this is the final answer. Okay, largest possible domain. Okay, I will continue the next question. Example 1.26, condition let f is equal to 3 pair is there, and same time g is equal to, there is also 3 pair is there. So what we have to find out? Find f is composite of g, at the same time can you find f dot g? Okay, first I am moving to find out f is composite of g. So what will happen? So given condition, solution, f of 1 is equal to 4, then f of 2 is equal to 5, then f of 3 is equal to 5. Then first next case g of 4, so g of 4 is equal to 1, g of 5 is equal to 2, g of 6 is equal to 4. Now find f is composite of g. What will happen? First one, g dot f of 1 isn't it, g dot f of 1 means g of f of 1, again g of f of 1 is equal to what the value? 4, g of 4, therefore g of 4 is equal to, answer is 1 is there. Therefore the first one, find f is composite of g means g dot f means the first pair 1 comma 1, the next pair g dot f of 2, f of 2 means what will happen? Again g of f of 2, so g of f of 2 is equal to 5, then g of 5 is equal to 2, therefore next pair 2 comma 2. Third one, g dot f of 3, now g of f of 3 is equal to, so f of 3 is equal to what the value? 5, again g of 5 is equal to 2, last pair 3 comma 2, This is answer for f is composite of G. Next condition, can you find f dot G? Okay, I have to check it. First one, f dot G, first condition 4. This is, we can write it f of G of 4. Again, f of G of 4 is equal to 1. Okay, f of 1 is equal to first condition 4 is there. Okay, next pair, f dot G of I. Again, f of G of I is equal to f of G of I is equal to true. Again, f of 2 is equal to 5 is there. Clear. Last case, f dot G of 6. F dot G of 6, therefore f of G of 6. Again, G of 6 is equal to 4. Check it. Is there any value for f of 4? There is nothing. Therefore, not possible. Okay, there is not value. So, first two values there, but if any one value also not equal means definitely we can say this is not defined. That's why they are asking the question, can we find? So, definitely we can say f dot G is not defined. Okay, how to finish a line? So, I will write it here. After finishing, you can write it here. Okay, the last line, f dot G is not defined. This is final line. Okay, the second part. Okay, I will continue the next question. (1.27) question, let f and g be the two function from real to real defined by f of x is equal to solution f of x is equal to 3x minus 4 and g of x is equal to x square plus 3. Okay, find f is composite of g and g is composite of f, or g dot f of x. Okay, first I am moving to find out g dot f. So, just add it on x. Okay, g of f of x. This is how to rearrange. The dot is converting for bracket. Again, f of x. Okay, now g of f of x is equal to value 3x minus 4. 3x minus 4. Already we know this is, for example, this is question, g of x is equal to x square plus 3. For example, instead of x, g of 3 means what will happen? Here we can write it 3 square plus 3. 9 plus 3 is equal to 12. For example, okay. Here g of x is there, but condition x square. Therefore, this is whole term considered for x, means instead of x we can write it 3x minus 4. So, what will happen? So, 3x, otherwise I will write it here. 3x minus 4 the whole square, remaining positive 3 is there. Okay, therefore, this is a minus b the whole square form. So, a minus b the whole square, formula a square minus 2ab plus b square. Therefore, 3x square means 9x square, again minus 2ab, 3 into 4 12, 12 into 2 24, minus 24x, 4 square means 16, another one constant value is there plus 3. Therefore, 9x square minus 24x plus 19. This is called g dot f, or f is composite of g. Okay, this is value, f is composite of g. Next condition, g is composite of f, that is f dot g of x. Again rearrange the dot converting for bracket, g of x. Again f of g of x is equal to x square plus 3. X square plus 3. Therefore, now the f of condition 3 into x. Therefore, 3 into, instead of x we can write it x square plus 3. Remaining minus 4 is there. Therefore, if you remove the bracket, 3 into x square means 3x square plus 3 into 3 9 minus 4. Therefore, final answer 3x square plus 9 minus 4 means plus 5. This is answer. Okay, this is g dot f, this is f dot g. Okay, I will continue the next question. So, theorem 1.2, condition, let f such that a tends to b, at the same time g such that b tends to c, be two function if f and g are 1 to 1, okay, f and g are 1 to 1, then we have to prove g dot f is 1 to 1. That is a condition, okay. Here some condition is there. I am moving to the question, the proof of the term. What is the value is there? A tends to b and b tends to c also to function. The both function also 1 to 1. What is the meaning 1 to 1 means? The arrow diagram, this is A, 3 arrow diagram is there, A, this is arrow diagram B, this is C, means this is A to B function is condition F, isn't it? At the same time B to C function is G. So now A to B related 1 to 1 function means B to C also 1 to 1. Then only we can say F and G 1 to 1 function. Therefore, we have to prove G dot F is 1 to 1. So we have to prove A to B 1 to 1, at the same time B to C 1 to 1, means we have to prove this is the line. A to C also we have to prove 1 to 1. How? Listen very carefully. This is already F is composite of G, means how to write actually. This is F is composite of G means G dot F. Then only we can say F is composite of G. We have to prove this is also 1 to 1. So listen. So after drawing, then I am moving to the given condition. So moving to the given F is first 1 to 1. So F is 1 to 1. What will happen? F is 1 to 1 means already we know f of x1 is equal to f of x2. This is implies x1 is equal to x2, means we can say it is 1 to 1. At the same time, next condition also given, G is also 1 to 1. So given G of x 1 to 1. What is the meaning G of x 1 to 1 means? G of x1 is equal to G of x2. Therefore, it is implies x1 is equal to x2, means this is also 1 to 1 function. Now, we have to prove the condition G dot F, isn't it? So, to prove G dot F is 1 to 1. What we have to do? G dot F of x1. This is 1 to 1 means the main condition it is implies is equal to equal, isn't it? This is also we can write it G dot F of x2. So if you remove the dot means the bracket G of F of x1 is equal to G of F of x2. Therefore, I'll write it here. Therefore, G of F of x1 is equal to, already we know the condition G of, listen very carefully, this is bracket of the term. Condition already we know G of x is 1 to 1 means G of x1 is equal to G of x2, means the bracket of the term is equal. Here bracket of the term F of x1 is equal to F of x2. Therefore, we can write now the bracket of the term will be equal. Therefore, F of x1 is equal to x1 is equal to f of x2. F of x1 is equal to f of x2 means the implies x1 is equal to x2. Therefore, we can say now G dot f is 1 to 1. Therefore, f is composite of G is 1 to 1. Hence proved, okay. I will continue the next question. Example 1.28, condition if f and g dot f are 1 to 1, both f and g dot f also 1 to 1, same time g is 1 to 1 is not true. So g is 1 to 1 is not true. Question also given, show that the statement, okay. So now to prove the diagram, but in your book given another one example diagram, you can check it when it's moving to the this diagram, okay. I will move on another one arrow diagram. This is consider for, this is x base means this is y. So x consider for 1, 2, 3. At the same time y, otherwise I'll make it here A, B, C, okay. Here the domain means this is called codomain, isn't it? 1, 2, 3, 4 and 5 is there. If you are comparing the function x to y means this is called f means So A true mapping with 1, B true mapping with 2, C true mapping with 3. So definitely this is 1 to 1. What is the definition for 1 to 1? Different element of X have different images in Y. It's clear, no? This is correct. Therefore, definitely we can say comparing the function f, this is the f, we can say is 1, 2. At the same time, g dot f also. Listen, I will move on another one array diagram. This is considered for another one letter, okay, P, Q, R and S. Now look at there, this is function of g, okay, function of g. Now I am comparing only, this is domain means this is codomain, this is called Z, okay, Y and Z, Y domain means Z codomain. Now clear, now mapping 1 to P, mapping 2 to Q, mapping 3 to R. Now this is considered for child mean this is mother, two child can become one mother, no, possible case, no. This is 4 and 5, it's related to yes is there. Now just comparing g dot f, f composite of g means how to read it actually, f is composite of g means definitely g dot f. So already we proved f is 1 to 1. At the same time g dot f also, comparing g dot f, listen, A true mapping with P, B true mapping with Q, C true mapping with R. But when you comparing this true function, only g means that's why given g is 1 to 1 is not true. So when you proving f also 1 to 1, g dot f also 1 to 1 means g function, only g function is not 1 to 1. Look at there, only comparing this diagram. Okay, 1 to P is there, 2 to also Q is there, 3 to mapping R is there, but 2 child 1 mother, it is not 1 to. That's why we proved clearly. In your book also the same question, last 2 line you can read, at the same time you can comparing that book diagram with this diagram, you will get it clear idea, okay. So I proved, okay, I will continue the next question. Moving to example 1.29, let f comma g such that real numbers to real number be defined as f of x is equal to, first condition, solution, first condition, f of x is equal to true x minus mod x. Already you know what is the meaning of mod x, plus or minus x, isn't it? Therefore, the first condition we can rewrite f of x is equal to when x less than or equal to 0, the negative value. Negative value means we can rearrange it 2x minus of, instead of x we can write it negative x, isn't it? So next case, x greater than 0. Greater than 0 means a positive value. Therefore, 2x minus of x. Then final term, f of x is equal to 2x minus into minus plus x when x less than or equal to 0. Again 2x minus x means only x when x greater than 0. Therefore, final term f of x is equal to 2x plus x means 3x, x less than or equal to 0. At the same time, x greater than 0 means value only x. But next case, g of x is equal to given condition true x plus modulus of x. Here also the same condition, g of x is equal to when x is equal to less than or equal to 0. What will happen? True x plus inside we can write it minus x. Then when x greater than 0 means true x plus x. Therefore, g of x is equal to 2x minus x, only single x when x less than or equal to 0. 2x plus x means 3x when x greater than 0. Now we are moving to find out the value of g is composite of f or f dot g of x, okay. So now this is the final answer, isn't it? So now we can write it in true ways. And the first way, so first way, when x less than or equal to 0, the small means what will happen? So negative value means, so negative value, the given f dot g of x, isn't it? So f dot g of x is equal to, we can write it f of g of x. Again, f of g of x less than. G of x less than only x, isn't it? Only x. Again, f of x is equal to f of x less than value only 3x, isn't it? The answer for the first term 3x. Now, the same condition we can apply less than over. Now, I am moving to when x greater than 0. What will happen? Greater than 0 means same condition f dot g of x is equal to f of g of x. Therefore, so f of g of x, isn't it? So now f of g of x is equal to greater than 0, g of x greater than 3x, isn't it? So f of 3x. Again, this is whole term f of x, isn't it? So f of x when x greater than 0, f of x when x greater than 0, only x. Instead of x, we can write it, what the value? 3x. See, look at there. When x less than 0 also, we have output 3x. When x greater than 0 also, we have the result 3x. Therefore, same output, isn't it? We can write it, we proved f dot g of x. F dot g of x is equal to 3x for all the value of x. Okay, output we can finish like that. F dot g of x is equal to 3x for all x value 3x. This is our final answer. Okay, I will continue the next concept. So, moving to one of the important concept, the concept name inverse of a function. So, in your book, page number 33, definition 1.9, isn't it? What the line is there? Definition 1.9, f such that x tends to y, at the same time the function g such that y tends to x, then defined by g of y is equal to x if when g of y is equal to x. So, g of y is equal to x if f of x is equal to y, one of the important condition. But before moving to the inverse of the function, the 4 important points also is there, isn't it? Yeah. So, working rule to find the inverse of a function, just read it. Okay, subdivision 1, 2, 3, 4. 4 point, important point is there. Working rule also, just you can read it. So, just I will move on with a simple example. Listen there. So, f of x is equal to 2x plus 1. Okay. So, f of x is equal to 2x plus 1. Instead of x, consider for 1 means 2 into 1. So, 2 plus 1 is equal to 3. Then, f of 2 means 2 into 2, 4 plus 1 is equal to 5. Then, f of 3 is equal to 2 into 3, 6. 6 plus 1 is equal to 7. Just making a diagram. This is considered for x, this is considered for y, means mapping 1 to 3. So, 1 to 3, 2 to mapping 5, 2 to mapping 5, 3 to mapping 7, 3 to mapping 7. This is one of the function, means f extends to y such that the same case to converting for invertible. Invertible also, that is called inverse. Listen very carefully. Okay, f of x considered for y means y is equal to the given condition 2x plus 1. From this term, how to in terms of y? Because just read it, in terms of working rule, find the inverse of the function. The second subdivision 2, write x in terms of y. Write x in terms of y means 2x is equal to y plus 1, bring it opposite sign means minus 1. Therefore, x is equal to y minus 1 by 2. Then subdivision 4, replace yx. Then subdivision third also f inverse of y, isn't it? Therefore, when you converting for f inverse of y, so f inverse of y is equal to, just we can read y minus 1 by 2. First, I am moving to, this is the term of the y value, take it 3 means what will happen? Okay. Now, f inverse of 3 is equal to, instead of y we can apply 3 means 3 minus 1 by 2. The 3 minus 1, 2 by 2, value 1. See, 3 comma 1, opposite term 3 comma 1, mapping 3 to 1, correct? No, that's why g function also y tends to x, opposite direction. Next term, f inverse of y value 5 means what the answer? 5. 5 minus 1 by 2. 5 minus 1 by 2 means 4 by 2 is equal to true. Now the pair 5 mapping to true. Look at there, 5 mapping to true. Next condition, f inverse of y means 7. 7 is equal to 7 minus 1 by 2. 7 minus 1 by 2 means 6 by 2. 3. 6 by 2 is equal to 3. The pair 7 mapping to 3. 7 mapping to 3. Therefore, the symbol, definitely we can say what is the meaning, f inverse of y is equal to y minus 1 by 2. Then main condition, f of x converting for y. I have taken for y means what is the meaning? Y is equal to f of x means when you can take it x means this is converting for f of y. So, true, fine, true important points. Okay, just you can read it, working rules to find out inverse of the function. As per the line, I have taken one example. Okay, so please listen, my dear students. One of the important concepts. If you have any doubt, please put in comment box. I am ready to clarify your doubts. Okay, I will continue the next session. Bye bye.